Alright, so, as it is Monday, and we are at the Milwaukee Makerspace, it is once again time for Model Monday. To a Gearbox Day. We're making gearboxes. So, there are many applications for a gearbox, particularly in a combat robot. Maybe you want to drive a weapon really fast, and you want to use a gearbox to increase the speed of your weapon. Or maybe you want to make a lifting mechanism and you got a motor that you need to increase the torque on. So you can increase the torque on a motor by putting a gearbox in. Maybe you want to make something that will just has a giant claw on it and will reach out and just crush your enemy with sheer strength. Those things are possible with gearboxes. So we're going to make gearboxes. A key part of today's of the gearbox is making gears. Mike, I think you have the Helical Gear Plus generator. Do you have Helical Gear Plus?
Where is that?
So you will need an add-on in order to do today's exercise. So if we go to the utilities section here in Fusion, utilities is, I should get my little magical pointer tool out here. You go to utilities, and then we'll go to add-ins, and then we'll click on the Fusion 360 App Store. And that will take you out to the magical internet, which is mostly cats. The internet. And that's why the internet's really slow, because it's run by cats.
Oh, it's run by cats.
Yes, I'm pretty sure that's how that works. Cats run the internet? Yeah. Cats and Jeff Bezos?
Jeff Bezos owns it.
Jeff Bezos might be a cat. Actually, we don't, I really don't know.
So I'm in stuff here. It's offering me trials.
I am not in stuff.
Rename body for all accessories. Gear generator is free.
I would look up Helical Gear Plus is what we want. And you can search there. For some reason, I don't have the internet right now. Let's go because reasons. There we go, now I got it. So
I got
Helical Gear Plus is what we want.
I need to download this.
Yeah, and then you will need to download it, but you will need to make sure you choose the correct operating system. So it's defaulted here to Mac.
Yeah.
And maybe you don't have a computer made by a fruit company.
Yeah.
So yeah, you'll download the Windows 64 image there. And then I believe you just have to double click on it and it will install. Once we've got our Helical Gear generator downloaded, you will find it in the Create menu. It's just hanging out there. You can make all sorts of gears. You can make gear racks. You can make herringbone gears, inner and outer gears, worm gears. It's a great little tool if you want to make gears, which is what we want to do. So I'm going to start a new document here, and I'm going to use this Helical Gear generator a whole bunch. So we're going to get through using this Helical Gear generator, and then really this is going to be mostly about creating joints here between the gears, so we can kind of get used to doing that. Alright, so if I go ahead and click on that Helical Gear Plus option, we get a little window that pops up here. So this is the add-in window here, and it has some options for us. So right off the bat, if we want to, we can click on the preview button, the little preview checkbox, and it'll give us a preview of the gear that we're making here. And I'm going to start off by making a gear that has 10 teeth. The module here, this refers to the size of the gears. So these gears are 3mm teeth. If you wanted to make teeth that are smaller, you could. You can make 2mm teeth if you wanted to, or you can make larger teeth if you wanted to make 6mm teeth. You could totally do that too. So that's how you change your tooth size. I'm going to leave it at 3mm. The helix angle refers to the angle that our gears are here. And something that I'll point out before I change that, we're actually not going to make angled gears for this. But I do want to point out that if you click on this little herringbone checkbox, you can make herringbone gears. And normally these are my favorite kind of gears to 3D print, mostly because they kind of stay aligned with each other. So you don't have to worry about your gears walking side to side. They just kind of stay aligned, which is really nice. But we're going to make just regular gears for our purposes today. Sometimes helical herringbone gears are hard to slide in and out of each other. You really got to do some more disassembly before you can slide them out. Right. But if you're going to 3D print them, yeah, exactly, yeah. So I'm going to change my helix angle to just 0 degrees. So we just got a straight up and down gear here. And I'm going to say oakley dokley. Alright, so now let's do that again. We're going to do that a couple of times here. So if I come up to my create menu and I come down to my helical gear option again, this time I'm going to make a larger gear. So let's start off by making a 2-to-1 reduction. So I'll make a 20-tooth gear. And I'll come down and I'll check on that little preview checkbox again. And you can see that it is overlaying right over the top of our first gear here. And there's kind of no way around that right now. We'll have to move it off to the side later. There are some positioning options here. So we can change the position that our gear is up and down. And we can align it to a specific plane. In fact, we'll do this on the next gear. We'll align it to a plane. But for now, oh boy, we gotta start over. Helical gear, 22 preview. You'll notice it saves your module. So if you changed your module and it remembers that I'm doing 0-degree angles here, it remembered my width of my gears, so it remembers a couple of these things from one to the next. But for now, I'm just going to go ahead and say OK. Now, to align these gears with each other so they mesh nicely, if I zoom in and I click on there, you can see there's a couple of circles, sketches that are kind of left turned on as part of these gears. And in order to get the gears to mesh with each other, these circles need to be tangent to each other. I don't think, you know what, let's give it a try. I'm not sure if this works or not.
Those guys.
But I've just been kind of aligning these gears manually. But I wonder if I make my 20-tooth gear component, my active component, and I spin down the little triangle where you can see all the stuff that is in that 20-tooth gear component, and I come to that sketch. There's a sketch there. called PO 60 millimeters, and I right click on it,
when someone is logged
and
in,
I say,
there's
can I
a
edit this
light,
sketch? Will it let me?
To ground, which will activate this relay, which will then open it.
I guess I
And then
can't even
green
edit this
here,
sketch.
The green and the yellow are dry contact. That goes back to the keyboard reader to.
Yeah,
so that
I didn't think there was a way to do this, but
uh,
I just wanted to go down that rabbit hole a second and make sure. So the way we're going to align these gears is just by moving them into place. So I'm just going to go ahead and click in the Modify menu, and I'll come down to Move Copy, and I'll choose, I'm going to pick my, I like picking the components that I want to move from my browser when I'm doing gears, because when I do it from my browser, it's going to stick my little move widget right in the center of my gear.
Yeah.
So if I need to rotate my gear later to make it look like the teeth mesh, my little widget there is already centered on the gear, so I don't have to worry about my widget being off center and rotating it in a weird way.
Yeah.
So I'll click on it in my browser over here, and then I'm just going to move it off to the side, and I'll kind of zoom in here until it looks like those green lines are pretty much tangent to each other.
Yeah.
And then I'll rotate it a little bit until it looks like it's like they're gonna mesh there.
So I'm just putting like a pigtail here just as an example.
There we go. And there, now it's kind of hard to tell on the screen there, but my two lines got really close to each other. In fact, if I highlight them just by clicking on them,
This kind of stuff?
you can see they're not quite touching, but they're pretty close.
Yeah.
It seems to be the way.
Yeah.
I'm sorry, I got a band-aid on my hand, so I can't zoom like normal. There we go. So that is two gears meshing with each other right there.
So right now I'm playing with the idea of.
Now I don't know if I'd call this a gearbox. I'd definitely call this a gear reduction. In order to make a gearbox, I would say you need to have more than one reduction. Maybe that's a decent definition of a gearbox. So I'm going to go ahead and click on the capture position button here, because I moved something, and whenever you move something in Fusion, it's going to give you this little option up here to capture your position. If you don't do this, it will probably ask you later on when it needs you to, and whenever it asks you, I always just say, yeah, capture position. So when I see that option up there, I just can make it in a habit of clicking on it and saying, yep, capture that position, it's where I want it to be. And now I can come up again to my helical gear generator. Actually, I should take a little stroll here and see, make sure you guys have.
I can't tell if I'm tangent here.
I will get them a little closer. Yeah, scoot them up so it looks like your gears are meshing.
Is there any way you can use those circles
Yeah,
there
I wish
and
there
set
was.
them up as like a tangent?
Yeah.
To auto align?
I couldn't edit that sketch that circle is part of. It wouldn't, when I found that circle in my, so you can find the sketch.
I found the circle.
Yeah, it's like PO 60.
Right,
When
right.
you right click on it, does it let you edit?
It lets you look at it, but that's about it.
Okay.
And also the circle did not move here when the
Oh.
gear moved.
Project for school.
So you moved the body and not a component.
Yeah.
So I'm just gonna go talk to Jake and see how the meeting went.
Oh,
That is a good
probably.
point. Yeah. So when you
Oh,
move.
that's what I did too.
Ah.
That's why I don't have mine nice circle.
Okay, cool. So
Okay.
that's a teachable moment right there. So that's a
Yeah.
so hit Command Z a couple of times, and go back.
Move body, move component, okay.
Yeah. So when we're moving the gears around, so if I click on modify and then move, we want to make sure that the object type we're moving is a component. So that way we'll move the body that is the gear, and we'll move any sketches, or anything that's associated with that gear, like sketches or other bodies that are
And
inside
you know
of there.
what? I couldn't click on that on the drop-down list.
Sure, over here.
We were talking about clicking on
Clicking on it in your
there.
browser.
I thought to myself, I like to do that also for that same reason.
Mhm.
Great idea, and it wouldn't let me do it. I clicked on the body
Yeah.
because it was a body.
Yep, exactly. Yeah, so if you got component select, or if you've got body selected, it won't let you choose a component. It would almost be nice if it was smart enough to say, oh, you're picking a component. Obviously you want to move a component. But it does not do that. Alright, so I'll move it over. And
Where's my circle lines?
there we go. And we want to get them pretty close. You can probably have a little bit of slop in your gears. We're not making parts for the space station, as some people around here like to say. But I do like it when they look like they're gonna mesh with each other. So, just from
And
aesthetic
even-
standpoint, and then I just kind of rotate it so you get the gears to look like they're gonna mesh.
Yeah, even doing it, it looks like those circles just line up just right when you mesh it up.
Yeah. And there's a little bit of gap going on between my circles. But I guess there's a little bit of gap in my gear spacing there too, so I believe that's what those circles are for.
Wow.
Alright, so now that we've got our first two gears in, let's place our next one. So I'll come up to my create menu again, and I'll go ahead and choose the Helical Gear Plus option. I'm going to make another 10-tooth gear because I'm going to make this 10-tooth gear attached to my my 20-tooth gear here. So I'll go ahead and choose the 10-tooth. I'll click on the preview option. Now it is probably actually previewing this gear. I clicked on my little preview radio button, and it doesn't look like it's appeared. But my guess is what's happening here is that gear exists exactly the same place as this other gear is. They exist on top of each other. So in order to see that gear, we'll have to bounce over to the position tab, and we'll actually use the items in this position tab for the first time. So I've got my 3mm module, 10-tooth, and if I bounce over to position, the first option there is to select a plane. So if I choose the surface of my 20-tooth gear as the plane that I'm picking, and then I choose a center point, so if I pick that center point, and then I pick what appears to be the center of this gear, I believe you can also pick the circle. Not really. It won't let you pick the circle. But there is a center point there, and it'll let you click on it when you hover over it, and then it just moves that gear right over. I find that you have to do these things in order. So if now, before I click OK, if I go back to my settings tab and change something, I'm going to do this. You guys don't have to. So if I go back to my settings tab, you can see like, wait, where'd my gear go? What's going on here? And it's still there. It just moved back to its original position. So this helical gear generator, you really have to do them step by step in order. They don't really like stick in place after you move it in position. So now I have to go back to my position tab and choose my plane again and choose my center point again. And then there it is. And then I'm going to say, Oakley dokley. Oakley dokley. Okay. I think it's there. Yeah, because you've got 3 components.
So- Ten teeth.
Yeah, and I've aligned it like right in the middle of that other view there.
Okay.
Here's a pro tip here. Let's say you've got 2 things that you want to align with each other. I'm going to move mine purposefully up place here, and I'm just going to capture position. So I got these 2 things. I really want them to be right centered with each other exactly. There is a tool for that. So in the Modify section, there is a tool called Align. And the tool kind of shows you, this does a really good job of showing you what it does here. So it's going to take these 2 faces, and it's going to align them based on that center point right there. And that's kind of what we want to do almost exactly here. So if I choose this Align tool, the object that you pick first is the object that you want to do the moving. So I want to move this gear over onto this gear here. So if I hover over the center of this gear, it gives me a little square with a little dot in the middle of it, right in the middle of that gear. And if I click on that, it says the from is selected. And now over here in my 2, if I hover over the middle of the gear here, and I click on that 2, now it bounced over, but they're like overlapping each other. So all I have to do is hit the little flip option. And that flips it around. So they're face to face now. Align is pretty handy. I like the Align tool. We don't do a whole lot of that, but yeah. If you ever make a normal joint as opposed to an as-built joint, the normal joint has an align function that works just the same way that's built right into this. You first align them, and then you tell it how to move. Success? No?
I think I got it now. Before it was halfway in there.
Alright. Okay, cool. Alright, so let's make one final gear. So from our create menu, I'm going to go ahead and grab the helical gear option one more time. I'm going to again make a 20-tooth gear here. So we're making a 4-to-1 reduction. Is that how that works? If I do a 2-to-1 and then another 2-to-1, then I've got a total of 4-to-1?
Yeah.
Okay.
Yeah, wise.
Alright, so I'll click on my preview button here and it'll preview that gear. Now, I'm gonna do the second set, the second tab or the third tab again, this position tab. I want this gear to eventually mesh with this 10-tooth gear. So I'm gonna align it right on top of it and then move it over. I think that'll be the easiest way to do it. So I've got my 20-tooth gear, and now the plane that I'm going to position it on is that plane right there. At the center point, it's going to be the center of that gear right there. And then if I say okily dokily and grab my move tool one more time, making sure that I'm moving a component, because that's fun for me. And I'm just going to move my component over, kind of keeping an eye on those green lines or those green circles until they look like they're about tangent to each other. And then I'll say OK. And then I'll capture that position. Alright, so that's where we're at so far.
How much is
10 millimeters is like less than 1/2 of an inch. Like 0.43 something, maybe. Cool. Yeah, cool.
393.
3.9.
There we go.
All right, cool. So now we've got our gears made here. Let's make them dance. Make them gears dance. So in order to make them function, which is something that Fusion excels at, is if we come up to our assemble menu, we're going to choose the as-built joint. Now, when we make a joint, specifically, well, I guess any joint is going to be made of 2 components. And the 2 components that we're going to make our joint from is each gear and the main document. So each gear is a kind of a component here listed underneath. And I think of the main document component as being the world. So each gear is going to rotate on the world that it lives in. It's like planet Earth. This is planet Earth right here, the main document. And I'm spinning around, technically connected to planet Earth right now, even though I'm not really connected to planet Earth. If that makes sense. All right, so I'm making a Revolute component. And I'm going to click on, I can either do this in the browser over here, or I can do it in my drawing view. So I can click on the component here in my drawing view, and then I can click on my main document component over here in my browser, which for me is called unsaved right now, indicating that I'm living dangerously, which is how I like to do it. On the edge. And then the final thing we need to do after we pick the 2 components is we need to select a snapping point. So
Hold on, Carl.
So we clicked on
I think I got lost here.
not a new component here, so cancel that. So we want assemble as built joint. And then the type joint we're going to make is a revolute joint. And if you click on your gear there, as one of your verse component, and then you click on your main document component as the second component.
That's this?
Yeah. Then you just have to hover your mouse over the middle of the gear there, and it gives you that little revolute point there where you're going to rotate around. And it'll give you a little animation. It'll do one full revolution, I believe. If you want to see that revolution again, you can just hit the little preview mode play button there. You can set a minimum and maximum for a joint. So a number of degrees it can rotate in one direction and a number of degrees it can rotate in another direction. For a gear, that doesn't really apply so much. Maybe in some cases, but not in our case. And I'm just going to say, okay. All right. Now we're going to do that 3 more times. So if we come up again to our assemble menu, we're going to choose as built joint. I'm going to choose this tiny little gear here again. I'm going to, not really doing this in order. I guess you could do this in order.
The main document component is the first in every one?
I make it the second, but I don't think it matters for a revolute joint.
Okay.
Yeah, I make it the second. Normally, the first thing I click on is the thing I want to do the moving. So I'm going to spin around. I am going to do this in order. I'm going to spin around to the opposite side of my joint here because I want to put my little snapping point on the outside, on the other side of this gear, so they don't exist on top of each other when I eventually do the small gear there. So I'll click on the gear, and then I'll click on the main document, and then I'll click on the center point, and then I'll say OK. And I'll repeat that for the small gear here on the other side. I'll click on assemble, as built joint. I'll click on the gear first, and then I'll click on my main document component second, and then I'll specify that center point there again. Now you'll notice, even though I guess they aren't connected at this point, so it only simulates one joint at a time. And then my last as built joint here is going to be between that component and that and my main document component, and it's going to revolve around there. When you make a joint, you get a joints folder, and in that joints folder is all of your joints, appropriately named. Joint 1, joint 2. You keep all your joints in a folder, right? Don't you keep your joints in a folder?
Where else would you keep them?
Don't you have to make like a rigid joint between this gear and that gear?
Well, you could. In fact, that is a way to do it. But I found that it was more difficult for me to do the math. So the way that I chose to do it is, here, we'll get there together here, Mike. Good question. So the next step here we're going to do is we need to make them move with each other. When I move this joint, I want this big joint to move, right? So if I click on assemble and then choose, I'm blanking on it, motion link. I want to link the motion between some joints. As I was saying, you probably should name these joints. I'm not going to do it right now because that's a lot of naming, but it's probably a good practice. All right, so if we click on our first joint, and then our second joint, which for me is on the other side of this, because these are meshing with each other, we have to do a reversed joint. But you'll see here, it's not, they're moving incorrectly. So this joint is or this gear is actually rotating around half as fast as this one is. So because there's a reduction going on there. So, well, actually the easy way to do it here is just to pick the number of teeth in each of your joints as your ratio. So I'm pretty sure if I do 20 and then 10, yeah. So then they mesh correctly. And they go super fast here. So I can stop this and then verify that that is indeed the right ratio by twiddling these gears manually. So let me bring that window back up there again. Edit feature. I believe the order in which you choose your joints determines the order in which they appear in this window. So I picked this gear first, and then I picked this gear second, the 22 gear first, and then the 22 gear second. So that's why 20 to 10 worked as a ratio there for me. So you don't have to do a ratio of 360 degrees. You can just keep the ratio whatever it is. So 20 to 10 works. So just the number of teeth in one gear and the number of teeth in the other gear. And then I'm going to say OK. Now, Mike, to your question earlier, you are correct. These gears technically do not move. They only move with each other at the same rate of speed, so they could be a rigid joint with each other. But if there's not a joint here, then I have to make my next joint relationship between this joint and this joint. And in our case right now, that's a really easy relationship because this gear and this gear are the same size, but they're still not going to be rotating at the same speed because there's a gear reduction here. So the way that I chose to do this to make it easier in my head is now next I'm going to make a relationship between this joint and this joint. So from my assemble menu, I'll choose the as-built joint again. I'm sorry, I'll choose the motion link again. And as the two joints I'm going to link together, it's going to be these two that are right on top of each other. And they're just going to move one to one because they're linked to each other. And that's all I got to do there. And then the very last motion link is just between this small gear and this big gear here. And again, that's reversed. And 20 to 10. And you know, once you get to the end of these gear joints, they start getting a little crazy. So you gotta say okay and kind of test it out by hand here and just verify, yep, everything is moving in the right direction. Nice. And then you just gotta link those last two up. Nice. Yeah. them so fast, I just have to go and say, all right, I'm gonna click OK, and then I'm gonna test it by using the gear that's the furthest to the left there. I think you gotta like double click the flag, and then you can. There we go. Nice. Now you can animate the joints all together if you want to. So, the very first joint, I'll choose to animate it based on that very first joint here. So revolute number 1. If I right click on it and say animate joint relationships. So if I just animate the joint, it'll just move the one joint. If I animate the joint relationships, it will move all of the joints that it is part of. All right, so we made the gear part of our gearbox. Let's make the sides. So if I want to make sides and shafts that hold these gears in place, I'm going to do that in a new component. So I probably don't want to do it in the main document component. I guess I could do it there, but I just like to have it nice and clean and have a new component that's the sides of this gearbox. So if I click on the Create menu and choose to make a new component, this new component is going to be the sides, and I say okily dokily. Now I am going to need to make some planes here. So I don't want to have my sketch exist right on this surface because if my side is brushing up against the side of this gear, there'll be some friction there and it won't be allowed to turn. So I'm going to come up to my construct menu and I'm going to choose to make a new plane, a new offset plane. So construct and then offset plane. I'm going to make my plane offset from the top surface of my gear here. And I'm just going to give it I guess we're kind of in the millimeter world here. We're in the metric, actually, we're probably always in the millimeter world. We just choose to ignore that fact. So I'm going to keep up this millimeter roll we're on here, and I'm going to make it offset by 1 millimeter. And I'm going to say OK. And now on that plane that I just made, I'm going to make a sketch. So I'm going to go ahead and say create sketch on that plane that I just made. And the first thing that I want to do that I like to do when I'm connecting some gears with each other is locate the center points of each one of my gears, because they're going to need some sort of shaft. And the way that I'm going to do that is I'm just going to project over that geometry that already exists. So from my create menu, I can come down to project include. I can come over to the project option, and I can project over each of the center points. I'm not sure if this is actually, if it's a center point of the gear or if it's giving me the joint as the option to project over. But either way, they're right there for us. And once I have those center points projected, now I can draw some circles over the top of them. So if I grab my center diameter circle from my create menu over to center diameter circle, and I can just choose a size here, like 5 millimeters seems like a good size. And I can draw 5mm circles. At each one of those center points there. I suppose let's make just a center rectangle. I think that'll be a good way to finish this off here. So if I grab from my create menu in the rectangle options there, the center rectangle, and if I just make my center rectangle right at the center of this middle circle here, I'll be able to make a rectangle that encompasses all the things that it needs to encompass there in order to connect our joints together. And then I'm going to say finish sketch. Now from my create menu, all I have to do is come out and extrude everything but the circles. I'm going to extrude it up like 5mm. I'm also going to, from my create menu, grab that extrude option one more time so I can punch all the holes in my gears. So the gears are going to need a hole in them so a shaft can go through them. And I can do that even though this is a different component than my gears are. So because I am drawing inside, because I'm extruding inside my sides component, and none of these things are in my sides component, it has not defaulted and changed the operation there, so I have to change it manually. So the operation here is still set to new body, but if I change that operation to cut, then it will start cutting through those gears here. And if you haven't ever done this before, you actually don't have to cut everything that it extrudes through. There's a little objects to cut drop down window here, and you can pick and choose which bodies you want to cut and which ones you don't. So you could uncheck some of these and it wouldn't cut through that one. And then I'm going to say OK. Now you can easily make the other side of this, but I'm going to skip that part because I wanted to show you a feature that I can't use because I'm in the wrong workspace. But you'll be able to use it. In fact, maybe it'll let me switch workspaces. Sketches. So, unbeknownst to me, I have been using Fusion 360 wrong for 10 years. When you click on your name up in the top left-hand corner, I have a team that I'm a member of, and I have a single user storage. I have been keeping everything in single user storage. These are actually different places in the cloud, and I've been keeping everything in single user storage, which apparently is the wrong way to do it. Because when you have something in single user storage, I guess there are features that you can't use, and one of those features is one that just got added in October that I'm pretty excited about. It is called Insert Fastener. Pretty cool.
What?
The Insert Fastener tool. So here, if I switch over to the team workspace, I gotta save that before it will let me switch over. Alright, so now if I click on Insert, and I choose Insert Fastener. Oh, can't do it unless I save my design. Alright, so save. It's not going to let me save my design, is it? Oh, it's going to let me save it. It's just going to... oh well. Just going to save it out here in the workspace that I don't use. And it's Gearbox. Alright, so now it opens up the Insert Fastener window. This is cool. There are many things. I've discovered there are many things about bolts that I don't know. So I invite you to take me to school here. I will say that I like to do my my socket head. Is that what they call it? Round head?
Socket head cap screw?
Yeah, I like the Allen wrench style.
Yeah, socket head cap screw.
Yeah. Oh, so if I go bolts and screws, and then I choose socket head, I picked instead of all standards, I picked metric, because I do like metric hardware.
Yeah, it is the better standard.
It is the better standard. I agree with our German friend. So now I can find a bolt that is just a normal bolt here. Like, I don't know what a binding head screw is, or what a broached hex socket head cap screw is, but if I just, there's a lot more options here than just like at McMaster-Carr. I guess broached is what we want. And then I choose a size, so this is a 5mm. Now this is the fun part. If I come out and pick this screw hole here, it automatically finds the other holes that are the same size, and it puts a bolt in them, and I can just spin around to the side view here, and I can just click and drag on this little arrow until my screws are long enough, or my bolts are long enough. So once it's got the other side on there, then that'll be long enough. I don't have to like do any measurements, figure out like, all right, how many millimeters is this going to be? I just drag it through, and then I've got my screws there. And then I can choose different finishes here. Maybe I've got black oxide finish. I could enter a part number. If I know a McMaster part number, I could enter it, and later on it'll let me generate a parts list based on the part numbers that I enter here. But for now, I'm just going to go ahead and say create and continue, and it's going to go ahead and make those nice hardwares for me, and this window will eventually go away, I believe. Or do I have to click close? I think actually I have to click close here, because I could go and pick other things. Yeah, I could go back and I could pick other holes that I want to put different fasteners in, or I could go and find nuts and like hex nuts here. Hex nut style 1, I guess. And I could find my 5mm. And here it recognizes that bolt there. This might my first time placing a nut. And I never placed a nut before, it's my first time. I want to let me place that nut. Yes, that's where it's going to go. And then I'm going to say OK. There we go. I've got nuts and bolts that are placed here. It actually made a fasteners folder here inside of my sides component. So it made a folder that it put all of those fasteners in. So this is pretty cool. I used to dig through the McMaster car parts catalog folder that insert McMaster, but then you got to align them yourself. It's not automatically aligning. If you got 50 bolts, you got to find all 50 of them and do them individually, as opposed to the fastener option here will just let you, it'll find all 50 of those holes the same size for you.
Can you export a list of them?
I believe that if I were to make a drawing from this design,
Oh yeah, okay, yeah.
that it would let me, it would find those as parts numbers when I inserted a table.
Yeah.
So if I place this, and then there are tables here, parts list. Yeah. So then it automatically found, oh, nope, it did not. These are my helical gears. It only finds top level components. It doesn't find nested components.
Okay.
Custom table.
I gotta enter them myself. You would think that that would be a thing, but maybe not.
Well, if not, I'm sure someone.
Oh wait,
will
first
come up
level,
with a script.
all levels.
There you go.
There it is. I just have to change it from first level to all levels, and then here's my
Nice.
nuts and here's my bolts. And if I'd entered a part number, it would show me that part number right here, so I know what to buy in the MasterCard. Cool. So that's joints and gearboxes more specifically. I'm gonna make my robot try to self-right itself if it gets knocked over. So I'm gonna put a little arm on a gearbox that tries to flip it back over to the right side. That arm could also potentially be used for lifting. So if you want to try lifting your opponent, that could be super fun. Next week is not a holiday. So it goes without saying on the 25th, I will not be present. You're welcome to come here on Christmas Day and draw things in Fusion 360. But you will, and my spirit will be with you, along with the spirit of the ghost of Christmas past
Christmas spirit.
and Christmas future. My spirit will be with you, but I will not be present physically. All right, so see you next week.